How many answers does that equation have? 0, 1, 2, 3. 1. I hear a vote for 1. I heard a vote for a lot. How many is a lot? Infinite. It has an infinite number of answers?
I feel like it doesn't do that. I feel like it has
More than 1? So somewhere between 2 and infinity? That narrows it down. All right, so think of what the sine graph looks like. The sine graph looks like this, and it keeps going, right? And it keeps going this way. And then if I draw y equals a half is right about here. So how many answers are there? A lot. In fact, there are an infinite number of correct answers. All right. So how are we going to write an infinite number of them? No, we're going to be clever. Well, we won't use dot, dot, dot either. All right. From the table that you've memorized, you should be able to tell me one answer. Sine of what gives you a 1/2? Pi over 6? He looks like he's still thinking about it. Yes? Sure?
Yes, actually.
Yeah, okay. So, there's one correct answer. X equals pi over 6. That's the answer in quadrant number 1.
And then it's 5 pi over 6.
And then sine is also positive in quadrant number 2. So we've got to find the answer in quadrant number 2, which is 5 pi over 6. And then Claudia said something. She said, if pi over 6 is an answer, then she said you can go all the way around and back to pi over 6. So another answer would be go all the way around, which is how far? 2 pi, and then add pi over 6 more. Or you could go around twice, which would be 4 pi and then go to pi over 6. Or you could go around the circle 3 times or 4 times or 5 times. Or I could even go backward, couldn't I? I could go backward 2 pi and then add pi over 6, and I could write it as a negative answer. All right, so here's how we write our answers. The answers are x equals pi over 6 plus or minus 2 pi k. Where what's 2 pi? That's one complete revolution. And then what's k? K could be 1 or 2 or 3 or 4 or however many times you want to go around the circle. It's like, yeah, the book might use n, actually. I always use k. The book might use n. I don't remember. And then the other answer is x equals 5 pi over 6 plus or minus 2 pi k. So there are an infinite number of answers, but we really only have to find 2 of them. We have to find the one in quadrant 1 and the one in quadrant 2. And once we have 2 answers, we have them all. Questions on that? Because every other answer is coterminal to one of these 2, which is a fancy way of saying just add a whole bunch of revolutions around the circle, however many you want. How about cosine x equals square root of 2 over 2? Again, you should have an answer memorized from the chart that you've got in your head. Pi over 4, I'm hearing. Plus or minus 2 pi k. So there's the answer in quadrant 1. And then what do I need? Not 3 pi over 4.
No,
all right, for sine, we use quadrants 1 and 2. Cosine is positive in 1 and 4. Yeah, he said 3. So I was waiting for him to correct himself. 1 and 4. So I need the answer in quadrant 4. 7 pi over 4 would be just a little bit smaller than 8 pi over 4, which would be 2 pi. So the other correct answer is 7 pi over 4 plus or minus 2 pi k.
So when you do like giving us what is on, you give us the cosine and stuff, and we have to find
Yeah. All right, how about, oh, go ahead.
No, what was saying? We would have to, there's no plus or minus left, so we have 4 different answers.
That's an excellent question. Oops, got to go back here. All right. Well, the next problem on my homework for WebAssign, as long as I'm doing homework off of WebAssign, it has cosine theta equals 0.8. Unfortunately, 0.8 is not one of those nice numbers that I've memorized on my chart. So what do I do?
We have to do the thing back in
What do you mean the thing we did back in 7.2?
we like added really 2 separate things and cosine.
No, easier than that. How do I get the theta all by itself? What kills a cosine?
Inverse cosine.
So the answer is theta equals cosine inverse of 0.8. So sometimes you're going to have to give me decimal answers. And this is an example. So I grab my calculator. I make sure my calculator is in radians mode. We want radians answers here. And I do cosine inverse of 0.8. That's, I'm going to round to, let's see, round to 2 decimal places it says on WebAssign. So I would write it as 0.64. So one answer would be theta equals 0.64 plus 2 pi k. And so I'm going to go with the WebAssign notation. I'm not going to write the plus or minus. WebAssign assumes k can be a positive or a negative.
So on the test, you can just accept, you just wrote.
On the test, if you write plus 2 pi k, perfectly great. I'm going to be very happy. Yep. But then I got to find the other answer. What's the other answer? It would be in the 4th quadrant. So how do I find the answer in the 4th quadrant? No, you don't add 270. Don't add 180. Don't subtract 180. All right, so here is the angle 0.64. I want this angle down here, where this would be negative 0.64. So if I want to write it as a positive angle, 2 minus 0.64. So I'm going to do that on my calculator. 2 pi minus 0.64. Actually, I wonder, this is something for you to try. I don't know if this would work on WebAssign, but it would be,
Put in 2 pi minus 0.64.
well, it would be perfectly fine with me if you wrote your answer as minus 0.64 plus 2 pi k. Minus 0.64 is the angle in quadrant 4. I don't know if WebAssign forces you to write it as positive answers. So you could also write it as 5.64 plus 2 pi k. Want me to try it?
Yeah.
Next problem. How about sine of x equals, give me a negative number that you like a lot.
Negative 63.
Negative 63. Okay. What's the answer to that equation? You actually made a very easy problem. You did. Negative 2 would have also been a very easy problem, by the way.
Is it usually like this?
No solution.
I was about to say, it's 0 to 1.
Sine can only go between negative 1 and positive 1. So if I give you a number like negative 2 or negative 63 or 106, the answer is no solution. That can't happen. All right, so let's try again. sine of x equals, give me a nice negative number that happens to be between negative 1 and positive 1. Negative 0.63. All right, once again, negative 0.63. Is that one of the ones that I've memorized on my table?
Definitely not.
Definitely not. All right, so I'm going to use my calculator. X is sine inverse of negative 0.63. My calculator says that's negative 0.68. So one correct answer is x equals negative 0.68 plus 2 pi k. In which quadrant does the other answer live?
2.
Well, I'm dealing with sine, and sine is negative here. Where is sine negative? In 3 and 4. This is the, when I use sine inverse always gives me the answer in 4.
So you want the product in 3.
So I want the answer in 3. All right, again, it
Would
might.
you do 180 minus the 0.63?
Yeah,
Or
I
would
think.
you do pi minus the 0.63?
All right, so here's minus 0.68. I want. So now the question is, do I want to write it as a positive answer or a negative answer?
You still want it as negative because it's still negative.
Well, it depends. If I'm going to write it as this angle, then I would write it as a positive angle. If I'm going to write it as this angle, I would write it as a negative angle.
So it's 3 and 3.
Well, no, I'm going to give either this positive answer or that negative answer. I'm not going to give both.
Negative answer would be easier.
All right, the negative one's easier?
Well, I think that it's both pi. It's either pi plus 0.68 or pi minus 0.68.
Well,
Can you tell us how to do it?
can I tell you how to do it? Well, you've got two choices. If I'm going to write it as a negative one, this would be negative pi coming all the way to here, but then I've got to go back this much.
So you're adding.
So it would be negative pi plus 0.68 would be one correct way to write it. If I want to write it as a positive angle, then I've got to think of this angle in quadrant 1, which is 0.68. So then to get to quadrant 3, what would I have to do? Add pi. So I can write it as either pi plus 0.68 or negative pi plus 0.68, whichever one you prefer. I think I'd go with the positive one at this point. I like positive things better than negative things, I guess. Pi plus 0.68. Calculator says 3.82 plus 2 pi. Okay. Questions on that? All right. Tangent x, we haven't played with tangent yet. Tangent of x is going to be the square root of 3. Is that one that I've memorized?
Yes.
Yes, it is.
It's the no, it's 5 or 6. Because it's right after.
It is
It's
5
right
or 6.
after
This is
1.
the first one.
Oh wait, the last one's.
Oh wait, it is big part.
I'm going with pi over 3. Am I right? Yes? How do you know I'm right? The right answer is you're always right. All right, you looked it up. It is pi over 3. It is pi over 3. Where's the other answer?
Quadrant 1.
That's in quadrant 1. Tangent is positive in quadrant 1 and is tangent is positive in quadrant number 3. All right, so tangent's a little different here. Oh, that's a bad representation. Oh, that's pi over 3. That's not too bad. So what's this angle over here in quadrant 3?
That would be 5
Pi plus pi over 3,
plus 5 over 3.
which happens to be 5 pi over 3. Correct. But here's the thing. If I start with pi over 3 and I add 1 pi, I get to this angle. What happens if I add pi again? I'm going to get back to there. Then what happens if I add pi again? Back to that one. For tangent, you really only have to find one answer. And then what do you need to do? Add pi, and then add 2 pi, and then add 3 pi, and then add 4 pi, 5 pi, 6 pi. So tangent, in a sense, is easier. You only have to find one answer, and then add pi k. Because the period of tangent happens to be pi. If you find one answer and add pi, it's going to give you the other answer. And then add pi again, add pi again. So tangent, in a sense, is easier than sines and cosines. To solve equations with tangent, you only have to find one answer. Isn't that nice? Half the work. All right, so what if I gave you tangent of x is -1? So x is pi over 4 is almost the right answer.
No, I don't want to say the
Negative pi over 4. Why negative pi over 4? Because that's a negative, so I need an answer in quadrant 4 or an answer in quadrant 2. So looking on my table, pi over 4 gives me a 1, but because of the negative, I need a negative pi over 4. And then plus pi k, that's all you need. You only need one answer.
Always going to be that.
Always going to be that easy.
Make it hard.
Are there ever ones that are cotan? Sure, why not?
I'm sorry, I just wanted to know.
Cotan of x, what would you like it to equal? 83. 0 would have been nice. 83.
83 is undefined.
Oh, no. See,
Oh,
83
no.
is only a problem with sines and cosines.
83 is 1 over 83.
So what I would do is I would rewrite this as tangent of x is 1 over 83. But remember, for tangent, the range of tangent is all real numbers. So it wouldn't matter what number was over here, it's going to work. I'm going to get an answer. So if I had a cotangent, the first thing I would do is convert it to a tangent and then solve. So I would use the tan inverse of 1 over 83. Calculator says that's 0.01. So x is 0.01 plus pi k. And I would do the exact same thing if I had a secant or a cosecant or any of those. If I had secant x is, got a number that you like?
500.
0. That's a good one. Secant x equals 0. What's the solution to that equation? It's not 0.
It's 1 over cosine.
So this would be 1 over cosine of x equals 0, which would be the same as cosine of x is 1 over 0, which is undefined. There's no solutions. When you're dealing with cosine, what's the domain? What's the range for cosine?
0, 2, 1.
The negative 1 to 1. Cosine can go all the way down to negative 1. So if I'm dealing with secant, I've got to have numbers that are bigger than 1 or smaller than negative 1. So if I have secant x equals 0, that's a no solution.
So if you're going to write it over like bracket or -1 to like 0.9.
No, it actually goes all the way to 1, so it would be bracket -1, comma 1.
But it's not including 0.
What do you mean I'm not including
You
0?
just said the 0 makes it no solution.
Right, so the range for this would be all numbers bigger than 1 or all numbers smaller than -1. Yeah. All right, so let's try a different one that does have an answer. Secant x is, so give me a nice number bigger than 1.
8,000.
7. 8,000, whatever you said would also work. Let's go with 7. Again, what I would do is I would convert this to a cosine. Cosine x is 1/7. And then I would grab my calculator. Cosine inverse of 1/7, 1.43. So I would have x equals 1.43 plus 2 pi k. Or, what's the other answer?
Wait, this is, yeah.
This is cosine. Cosine is pretty easy. You just go negative 1.43 plus 2 pi k. For tangent, the difference is tangent has a period of pi.
Okay.
Cosine and sine have period of 2 pi.
Okay.
So that's the difference. Other questions? All right. How about sine squared x minus sine x equals 0. How would you solve that equation? Factor. It's quadratic. It's quadratic in disguise. You see an exponent. When you see an exponent like that, that's a quadratic equation. How do you solve quadratic equations? You factor, or you use the quadratic formula for quadratic equations. I don't want to use the power reduction here, because if I use the power reduction, I'm going to end up with a cosine of 2x and then a sine of x. My angles won't match. So you're really not going to use power reduction formula here. What you're really going to do is you're going to factor. So we would factor, we would write this as sine x times sine x minus 1 equals 0. How does that help? Well, what can you do once you factor? Like if I gave, let's start with an easier equation. If I gave you y squared minus y equals 0, you would factor. Because I like factor. And then what would you do after you factor? You would set each piece equal to 0. That's correct. Again.
Would we be allowed to say let sine x equal y and then we'll go back over to sine x to the very
If you want to. That adds extra steps. But basically that's exactly what you're doing. After I factor, I set each piece equal to 0. So sine x equals 0, sine x minus 1 equals 0. So sine x equals 0 or sine x equals 1. All right. So when does sine of x equal 0?
Pi over 6.
No.
Pi over 6.
No.
First one. It's 0.
Sine of 0 equals 0. So it would be 0 plus 2 pi k. Or when else does sine equal 0?
When it's
2 pi is a correct answer, but that's already covered here. 0 plus 2 pi would be 2 pi. 1? Sine of 1 is 0? No.
oh, it's the opposite side, so it'd be sine of that side.
180 degrees. Put it in radians, please.
Pi.
Pi, just pi. All right, so you guys got to start remembering your unit circle. Remember, this is the point 1 comma 0, and this is the point -1 comma 0. So sine is the y number, so sine is 0 here and here. Where's cosine going to be 0? Pi over 2 and 3 pi over 2. All right, so we're halfway done. When does sine of x equal 1?
Sine of x equals 1 and 5.
So this is the point 0 comma 1, and this is 0 comma -1. So when does sine equal 1? A pi over 2? And that's the only spot, isn't it? So here we only get one answer, pi over 2, plus the 2 pi k. Questions on that? All right, one more for today. How about cosine squared x minus 3 cosine x minus 2 equals 0. No, there's no y's, there's only x's. I need to make that a plus 2. Let's make it a plus 2. You factor, just like you would if it was y squared minus 3y plus 2. It's a factor problem. All right, so we're going to factor. It's got to be cosine and cosine in front to get the cosine squared. And then how about the numbers on the end? A -2 and a -1? Yeah, you factor just like you did before. Nothing new there. So we're going to have cosine x minus 2 equals 0, or cosine x minus 1 equals 0. This one gives me cosine x equals 2, and this one gives me cosine x equals 1. When does cosine x equal 2? Never. So this one has no solutions over here. No answers from that side. We can just cross that whole slide off. It didn't do us any good at all. When does cosine x equal 1? Not pi over 2. Not pi over 6. As 0. Look at your unit circle again. Cosine is the x numbers. When is cosine equal to 1? Right there. Where else is it equal to 1? Nowhere, except for the coterminal things. So our answer here would be x equals 0 plus 2 pi k. That's the only answer.
And that's about as hard as it will.
In this section, that's about as hard as it'll get.